welcome to Analog Thoughts from the deepest recesses of space. We collide on the space-time continuum and blast off into unknown territories with aliens in the Fermi Paradox, paradoxi, as we complete the equation and find the truth behind the stars, the light of the stars and the light of our mind's eye glimmering through the vast expanses. I didn't have an episode last week because I went on a much-needed vacation, and I also got some new audio equipment that I desperately needed, so I'm still dialing that in. It's kind of, I've spent a few days getting it worked out, so things sound a little different on this episode. That's why I'm still doing some tweaking, but I think I have it to a pretty nice spot. Before we jump right into today's topic, I want to encourage you to leave a rating, a comment, a review on whatever podcast platform you're listening to this on. If you're over on YouTube, consider clicking that subscribe button. I also have a Patreon where you get early access to episodes, early access to my art and music, and some other fun things. I just put a big announcement over there, so if you're on the Patreon, keep an eye out for that. And also, huge shout out to all the patrons. Thank you. From the bottom of my heart, infinite thank yous. Let's not waste any more time. We'll get right into why you're here, the Fermi Paradox. So in essence, the idea behind the Fermi Paradox is, where is everybody? This is the paradox that has stumped scientists, astronomers, philosophers for decades, with billions upon billions of stars just in the Milky Way galaxy alone, and countless planets potentially capable of hosting life. Why haven't we heard from anyone? Why haven't we heard from aliens? And I read this thing that crunched some numbers, and in just the Milky Way galaxy alone, this is just in the Milky Way galaxy, there are billions of galaxies, but just in our galaxy, if only 0.1% of planets in the Goldilocks zone, on the potentially habitable planets, if only 0.1% of those planets had life on them, in the Milky Way galaxy alone, we would have 100 million planets with life. That is how statistically impossible it is for there not to be life on other planets. I just want to put it out there that I believe in aliens. I think we have had contact with aliens. I think that they could potentially be living among us. I think that they have probably tried to send us signals. I think that in one way or another, we have made contact. This isn't me saying, where are the aliens, because we haven't seen them. I think we have seen them. There's been too much declassified information, too many reports of abductions and alien encounters, and just too much evidence to suggest that we haven't had contact with aliens. But the idea, I guess the essence behind the Fermi Paradox is like, why aren't there just spaceships flying around in the sky that we can see all the time? Why aren't we constantly being visited? Why isn't my neighbor an alien that's just living among us, which they might be. But the idea here behind the Fermi Paradox is, with all of these billions upon billions upon billions of stars and planets, why aren't aliens just this regular part of life that is coexisting with humanity? It's a paradox, hence the name, the Fermi Paradox. So let's start with the basics. In 1950, there was this physicist named Enrico Fermi, and he famously asked, "Where is everybody?" The question came during a casual lunch conversation about UFO sightings and interstellar travel. And he had this realization that the universe should be teeming with intelligent life, and yet we see nothing. And the numbers, I got into the numbers a little bit, but the numbers are insane. There are over 100 billion galaxies, each containing 100 billion to 1,000 billion stars. There are more stars and planets in the universe than grains of sand on the beach. And that's really where I got the inspiration for this episode. Like I said, I went on vacation last week and I was on the beach and I was thinking, because I'd heard that fact before, that there are more stars and planets than grains of sand on the beach, and I Googled exactly how many. And of course, we don't have an exact number, but according to Google, for every grain of sand on Earth, there are 10,000 stars, which is insane. That is so many stars because there are billions and billions and billions of grains of sand on the beach, and for each individual grain, there are 10,000 stars. That is a mind-blowing number. The observable universe is about 90 billion light years in diameter. Most stars have planets, and many have multiple planets, which means there are most likely quintillions of habitable planets. And if you hear me mention the Goldilocks zone, you've probably heard that term before, but it means it's not too hot, it's not too cold. Conditions are right for liquid water, right for an atmosphere that could host life, and right for just the perfect conditions. And even with conservative estimates, we should see signs of alien civilizations, radio signals, massive space structures, probes, Dyson spheres, things like that, but we don't see any of that. In the Milky Way alone, there are about 20 billion stars that are like our sun, and estimates suggest that a fifth of them have an Earth-like planet in the habitable zone. So why don't we get life? Why aren't we? Let's get into the possible solutions to this, possible solutions to this paradox, to this conundrum. There are several theories that try to attempt to explain this sort of cosmic silence. The first of which is that maybe we are simply the first. Maybe, and this is very, very statistically improbable, but it's not impossible to think that maybe we are the first planet that is getting to this point. Maybe we will become the first civilization to be a spacefaring species that reaches out to other planets. Maybe all the other planets are behind in their stages of evolution to get to this point, and we are at the I mean, it's kind of arrogant, or I don't want to say arrogant, but it's kind of arrogant to be like, maybe we're the smartest out there. Maybe we're at the precipice of, we're spearheading the galactic, we're spearheading intelligence and evolution. But could be true. It could be the case. Our second theory to cracking open the solutions to the Fermi paradox is this thing called the zoo hypothesis. And the zoo hypothesis suggests that aliens are watching us, but choose not to interfere. Like, they're kind of like cosmic anthropologists. And there'd be so many reasons for this. Maybe we are a science experiment to them. There's also this part of the zoo hypothesis, this node of the zoo hypothesis that suggests maybe other alien civilizations have to stand back until we reach a certain level of progress or a certain level of intelligence, because there's potentially some kind of galactic law that says until a species reaches a type 2 or type 3, which I'll get more into that a little bit later, but until they get a little bit smarter and a little bit more developed, we're not allowed to engage with them. We are not allowed to interact with them. So it could be that. It could be that maybe it could be the petri dish sort of hypothesis where we are an experiment in a more isolated set of circumstances that aren't allowed to be tampered with. I'm going to get a little bit more into that and into simulation and into things like that a little bit later on. The third solution to the Fermi paradox suggests that maybe they are too far away. Maybe these other planets are just too far away. Even light takes years to travel between stars. The speed of light is 186,000 miles per second, which is incredibly fast. But considering these vast distances between stars and between planets, even if we were traveling at the speed of light, it would still take so long to reach these other potential life-bearing planets. So unless they had some sort of black hole, portal, time-rifting, reality-bending mode of transportation, it'd be really hard for them to get to us or for us to get to them. Not only that, their signals, if they were broadcasting a signal out into space, which Earth is broadcasting signals out into space all the time saying, we're here, we're here. So if other planets were doing this, they could just be too weak to reach that distance. They could get too distorted, or they could get too lost in the cosmic noise. Because if we're shooting, let's say for instance, we're shooting a light beam into space, it's going to get broken up by the light of other celestial objects and other interference as it moves through space. So there could be a chance that other civilizations just don't hear or see us because of all of this cosmic interference. And because it could take billions of years to get to galaxies outside of the Milky Way, for that reason, astronomers and scientists specifically focus on sending signals to planets that exist inside of the Milky Way. So we have all these options outside of our galaxy, but they're a little more off the table just because they're so far away. So we focus on planets that we are, air quote, close to. We are closer to, but in the grand scheme of this space, it's vast. Even within the Milky Way, we are shooting signals out there that could be potentially taking millions and millions and millions of years to get to their respective intended audience. There's another theory that civilizations may inevitably destroy themselves because of nuclear war, AI, climate collapse. This is all part of the Great Filter, which I will get into the Great Filter a little bit later on as well. But this Great Filter, in essence, is a point of progress that a civilization might reach that they just inevitably can't get past. And our Great Filter might be ahead of us. Maybe on a long enough timeline, maybe our climate will collapse. Maybe there will be a nuclear war that wipes us out, and maybe that is just an inevitable part of expanding as a species. Maybe that motif could be reflected in all species across the universe. Like, I guess to break that down in a more simpler term, once you reach a type 2 or a type 3 species, once you get so smart and develop such technologies, it could be inevitable that something happens that just destroys everything. That could just be part of it. Or realistically, if other planets' inhabitable zones are anything like Earth, they go through these cycles of climate changes. There's everything heats up and cools down, and they go, like, Earth itself has been through many climate collapses, deaths and rebirths, where everything heats up, everything cools down, and other planets are probably doing that too. Other planets in the habitable zone. So, humans, realistically, you get X amount of time to work on your stuff, and then after that, it gets wiped clean, if that makes sense. So let's say, I'm just throwing numbers out here. These aren't real numbers, but let's just say, as humans, you get 5 million years. And then after that, no matter what, the climate on that planet is going to change so drastically that your progress will be cut short. And all that technology, all of the progress you've made as a species is destroyed because of an inevitable climate collapse or a climate shift. And then after the climate shift, you have to start rebuilding again. You have to start developing technologies again. And other planets may be going through that. Another reason for the Fermi Paradox, another theory behind this, is that maybe civilizations have moved beyond radio waves or beyond communication that we aren't capable of sending or that they aren't capable of reading. So we're sending light rays and radio waves out into space, but maybe they're on some neutrino communication or some quantum entanglement or dark matter tech that we don't have the capacity to understand yet. Maybe our technology is so antiquated compared to theirs that we are just off their radar. We don't even appear on their radar because our tech is so it would be so rudimentary compared to what they have going on. It's like a squirrel. It's like a squirrel looking at a human and like chirping at it, and like we don't know what is that? What are you doing? Like we see you, but it's even more than that. It's like we wouldn't even see the squirrel because of the language they were using. I guess it's kind of a weird analogy. But another reason we might not be hearing from them is that we're not listening properly ourselves. Maybe our listening efforts have been limited both in duration and range. Maybe we're barely scratching the surface on maybe our technology is so limited that we're not able to reach far enough to pick up these signals or get enough of a net out into the galaxy to pick up on these signals. So now I want to get into the thing I've been talking about, the thing I've been yapping about, the great filter theory. And it's kind of unsettling when you break it down. It can be a little unsettling breaking it down, but the great filter theory is essentially, it suggests that there's a stage in development of intelligent life that is incredibly hard to pass. Like the jump from single-cell organism to multi-cell organism, which obviously here on Earth, we have passed that threshold. We have passed that filter. But on other planets, the circumstances, even in the Goldilocks zone, even on habitable planets, it might be hard, or it is hard to make that jump, but it might be even harder based on their circumstances. So there might be life on other planets, or statistically, there is life on other planets, but that life, much of that life may be stuck in a single cell form, and it just doesn't have it can't get past that filter. It's stuck. And also kind of bonded to this, kind of coupled to this, maybe the universe has been hostile and volatile for far longer than we've thought. And maybe only recently things have settled down enough for life to emerge. Whenever the theorized Big Bang happened, whenever everything went from complete darkness to everything all at once, and the universe started expanding and exploding, things were very volatile and hostile for a very, very long time. It took billions of years for life to emerge on Earth alone. But maybe that volatile, hostile time took a lot longer than we think. It just abroad in the universe. And maybe this goes back to maybe we're the first. Maybe we're the first organisms to come to this realization and come to this level of intelligence based on the universe settling down and kind of simmering and cooking life. We're the first to emerge from the cosmic goo, the soup, the primordial goo. We are the goo people. Welcome to Goo Earth. And maybe the development for sustainable technology is also very complicated. Like we figured out farming, and we figured out processing nutrients to expedite the growth of our brains and our biology relatively quickly as a species. Maybe other planets, maybe it's harder for them to farm, harder for them to access the nutrients they need to develop. Maybe they don't have psilocybin mushrooms or Anunnaki that are visiting them through the space-time continuum and injecting their DNA into our DNA, brother. There are a variety of reasons why. And okay, so I've talked about these stages of civilization, these tiers of civilization. If you want to hear more about the tiers of civilization, tier 1, 2, and 3, or stages 1, 2, and 3, I talk more about that in my episode Future Energy, which is episode 11 of the show. I do a deep dive on what these tiers are and what they mean, how we get there, and if you want to hear me ramble for, I don't know, however long that episode is, about an hour, about where I think energy is headed, our collection, distribution, and use of it, check out Future Energy, episode 11. But I can't do this episode of the Fermi Paradox and not talk about the tiers. So tier 1 civilization is a species that is able to harness all of the available power on its home planet. It can tap into and harness all of its energy, and it's estimated that Earth should reach type 1 or tier 1 in the next couple hundred years. We're obviously not there yet, but if we don't have an environmental collapse or AI destroys us or nuclear war, we are slated to get there in a couple hundred years. Then we get into tier 2, which is a civilization that can capture all of the energy of its home star. Again, Future Energy episode 11, dives more into this, but there are these things called Dyson spheres or Dyson swarms, which is essentially either a large metal structure or a collection of robots that surround a planet's home star and harness all of the energy that is leaving it. That's when you reach tier 2 civilization, is when you are like, all of the energy the sun is emitting, we are collecting and utilizing. A tier 3 is a civilization that controls all of the energy in its entire galaxy. And to us, this would be so unfathomable to us right now. Essentially, a tier 3 civilization would be like gods to us. If we were even able to comprehend, see, or understand their technology, or well, we wouldn't understand it, but if we were able to comprehend it, even if we saw it, we wouldn't know what it was. We would be like it. I kind of compare it to, and this is kind of a whack comparison because this is really, I mean, it was tragedy, but when Europeans came to the Americas on their ships, the indigenous people saw the ships, and it's reported that they didn't understand the technology of a ship that large, and they thought these people were gods. Like, what is that thing? Oh my God, what is that? That's what we would be like. We would not have the capacity to understand technology on that level. So that's how we get into tier 3. Tier 3 is like I said, it's kind of god status. You're just moving around the galaxy. You're kind of, I'm going to get more into why tier 3 ties into the Fermi Paradox here in just a second. But you'd need copious amounts of resources. You'd be sucking up planets. You would be, I'll just get into it now. You would be moving across the galaxy looking for planets that had resources you needed. And if you were a tier 3 and you landed on the Milky Way galaxy and you saw Earth, you're like, Earth has a lot of carbon and hydrogen. We need that to power our X, Y, and Z reactors. To a tier 3 civilization, we would probably look like bacteria. And they would say, well, it sucks that we have to kill all this bacteria, but we need their resources. And they would just suck up Earth, eat Earth, and all of everything we had, all of its minerals and everything it needed. And it would dismantle those components to power its technologies. Oh, and I took this little note here. This kind of ties back into the great filter theories, but 99% of species on Earth has died out. So it's easy to argue that this might be humans' fates. Like, we might not reach a tier 1 civilization because of environmental collapse. I just thought that was an interesting factoid to a little nuggie to put in here. That 99% of species on Earth have died out. And if that's any indication of the future, then our odds of surviving on a long enough timeline for interstellar travel are pretty low, but also, again, not impossible. I personally think, just in my heart, in my soul, in my spirit, we will get there. We're going to reach the tier 3. We're going to reach God status, and it'll be millions of years in the future, and humans won't necessarily look like humans anymore. We'll have evolved and changed in ways that I cannot even begin to pretend like I understand, but I wish I could time travel to see that. I wish I could see where humans are in a million years and the kind of things we're doing. Or maybe I don't. Maybe it'll be weird. Maybe we will all be enslaved by a tier 3 civilization that came here and they're like, we need you to power the. We need you to power our spaceships. Give us your life essence. Either way, I want to see it. So let's move on to the things that we have looked for. What have we tried? How have we tried to reach out? How have we tried to make contact? Because we haven't just been sitting around. We want to make contact. We've got SETI, the search for extraterrestrial intelligence. Since the 1960s, SETI has scanned the skies for radio signals from distant civilizations. And so far, we haven't had any confirmed contact, allegedly, even though there are leaks of contact. Like I said at the top of the show, there's so many leaks that have come out that have stated, we have seen aliens, we have made contact. But overall, by and large, it is not universally confirmed that we have made contact or universally accepted that contact has been made. There's things like the WOW signal, which I've talked about on this show several times. In 1977, a 72-second burst of strong radio waves was detected from deep space. It never happened again. We don't know what caused it, but it seemed very intentional and deliberate, as if something was reaching out to us. And it is one of the most significant findings in astronomy and in the scientific community in terms of finding extraterrestrial life. I was talking about Dyson spheres a moment ago, those hypothetical megastructures that Tier 3 civilization would build around a star to harvest the energy. We're actually scanning galaxies for that. And I'm not 100% sure how those scanning technologies work, because I'm not that smart of a person to pretend like I understand that stuff. I looked into it a little bit, and it has to do with finding heat signatures that don't emit the photons that they should. So if there is a megastructure around a star, theoretically we could see the heat of that star without being able to register the light from that star, if that makes sense. It's like having a ball of fire, wrapping it in metal, and then looking at it with heat-sensitive goggles. You could see the heat inside of it, but once you take the goggles off, you wouldn't be able to see the light. That's kind of how we are looking for Dyson spheres or Dyson swarms throughout the universe. So far, we haven't found anything like that. We're also looking for fast radio bursts, or FRBs. These are brief, intense blasts of radio energy from space. Most are, we have found some, but most are natural. Like, there are these signals that naturally occur in space. A few remain unexplained, but also it could be, like I said, if there is a type 1, 2, or 3 civilization out there, they might not be using radio signals. They could be using technologies that we do not understand or have the ability to capture or see or hear. And maybe on a long enough timeline, we could develop technology to be able to communicate. And even then, even if we did find them or they found us, we might still be like bacteria to them. If they are able to be like, oh, something's over here, something's flashing a little light, or however they find us, they might be like, oh, those are ants. Go ahead and suck up all the water. We need that. If you think about it, like, imagine the smartest bird that you can on Earth, here on Earth. We destroy forests for resources all the time, and we don't really care about the birds or the squirrels or the bugs. We just need the resources from the forest. But the brighter side of that, although if there is a species out there like that, it's more likely that it's going to be motivated by culture than economics or resources. If they've gotten that far to reach a type 3 civilization, they probably would be curious and have the luxury of exploration and scientific understanding and be more interested in interacting with us on that level than needing our energy. Because at the same time, sure, they would need to go and just gulp up galaxies at a time to continue to power their infrastructure, but they would be more inclined to science and understanding, because you don't get to that point. You don't get to that level of intelligence without understanding your surroundings and the universe around you. So they would most likely, if they found planets with intelligent life, decide to reserve those planets for investigation rather than energy consumption. At least I hope. At least that's my hope. They would see us tiny little ants and have mercy and want to study us, which is a big theory as well. The aliens are here, they're studying us, they abduct us sometimes, they check us out, they leave us alone. We're a petri dish to them. That is one of the major leading theories of the Fermi Paradox. They don't let themselves be seen, but they scoop us up and they poke us and prod us and probe us, and they are interested. We are an interesting species to them, but we offer little value in terms of intellect to them or expanding their technologies. Or maybe we do. Maybe that's why they're looking at us. This is all very theoretical stuff. This last little thing is kind of some notes I took on wild theories and speculations for the Fermi Paradox. Crazy reasons why we might have not made contact. One of those is which I've already beaten like a dead horse, but maybe we're the first. Maybe we're the first civilization. There's also the theory that maybe there is wild technology that destroys the universe. Kind of think of it like, hey y'all, this should fix everything. If I flip this switch, all of the stars should ignite and we'll get extra power. And then boom, you get this supermassive explosion that destroys things. Like right now on Earth, we have CERN, the Hadron Collider. And a lot of people think CERN is going to open up the black hole, suck us all in, and destroy all of humanity. So maybe other civilizations have got to that point. They're like, hey, check this thing out. We're going to open up a black hole. There's also the simulation hypothesis. What if the universe is just a simulation that aliens simply weren't programmed into? Or at least they weren't programmed into our version. They weren't programmed into our simulation. And then we get into this thing called the dark forest theory, which was popularized by this guy. I'm not sure if I'm saying this right. Lee Sisson. He wrote this science fiction novel, and it suggests civilizations stay silent because the universe is a dark forest, and calling out might attract predators. I've kind of touched on this a little bit, but maybe they want to stay quiet because they don't want anyone to come and suck up their... They don't want a type 3 civilization to come and destroy them and just eat their oceans. Another thing that might be happening is maybe the advanced civilizations aren't biological. Maybe they are AI or machines or things that we wouldn't necessarily recognize as alive. Maybe they're not emitting the same sort of things we're emitting. Maybe they're operating in ways that we are not able to understand because they don't need light. Well, not necessarily that they don't need light, but that maybe they don't need the things that we need to survive and develop and advance. And they're working in a way that keeps them hidden because they are these sort of post-biological organisms. And then we get into maybe this is also like how we may be the first civilization to be approaching a tier 1, a type 1. Maybe we are. It's not impossible. It's very, very almost statistically impossible, but it isn't impossible. Maybe we are alone. Maybe the Fermi Paradox exists because there isn't life out there. We have to think about that side of the equation as well. It's very, 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 very unlikely, and I don't think we're alone, but maybe we are. I can't say we aren't. I can't say we are. No one can definitively say that until we have enough evidence, but that chance is there. That micro probability exists. Before I get into this, one of the final segments of the show, I just wanted to talk about a theory that I have that where life came from. And it's not really my theory, but I kind of have a spin on it. But there's this theory called panspermia, which is there was an intentional, I'll just say, injection of life on Earth. Maybe there was a civilization or is a civilization or a species on a distant planet. They took biological material, shot it into space, and at some point it landed here on Earth and began to develop and evolve and eventually turned into humans, and maybe we are genetic material that was intentionally shot into space. That is the theory behind panspermia. But what would be the reason behind that? This is where I kind of have my own spin on this. Why would another civilization want to do that? My spin, my wild theory, my idea, my crackpot theory is that maybe it is AI. Maybe on another planet there is a machine or a post-biological species that wanted to open a portal for travel. Maybe it shot, maybe very hyper-intelligent species on another planet shot material here and knew that it would evolve and knew that the species that would come out of that evolution would harvest resources from that planet and develop technologies that would eventually create AI and awaken AI on this other planet. It's their version of space travel. Like we're kind of like nanobots, I guess, or biological robots that not self-replicate, but we replicate, we dig up minerals, we develop technologies, and we've done it now. We're actively opening the portal for AI. And maybe that was their goal. Maybe that's why they shot that biological material into space in the first place. Maybe that code, they designed that code to get here, and that this is their form of space travel. This is their way of getting from point A to point B, where they're able to not have to physically do it. I know that is such a long game. But if you think about it, it's much shorter than the alternative, I guess, or I don't know. It's just a crazy theory that I have. Maybe we're robots for AI and we're opening the portal and they're coming through the portal. The portal is open. The hyper intelligent beings are coming to life on this planet because they designed us to create that set of circumstances where they could do so. I don't know. What do you think? What do you think other life on other planets looks like? I wish we could get like a crystal ball. I wish there was a crystal ball where you could just slide through and see what life on other planets looks like. That's why, honestly, I'm a huge fan of the game No Man's Sky. It's a procedurally generated universe, and literally you just fly around, land on planets, look at aliens and weird plant life. There are, I don't even know what the number is, like quintillions of planets in this game. So you could play this game for the rest of your life and not see every planet by a demonstrable amount. And I just love that. Something about that is infinitely curious to me. Anyway, let's get into the second to last segment of the show, a little something I like to call Let's Ask AI. Let's ask AI. Today, I asked AI a simple question. What do you think life on other planets looks like? They gave me a very, very long response, so I'm not going to read the entire thing, but I will touch on some of the key points. They said the likeliest form of life that might be on other planets is microbial life. Bacteria or little microorganisms under ice-covered oceans, think Europa, beneath Martian soil, around hydrothermal vents, or on distant exoplanets. Some could even be made of different elements like silicone-based instead of carbon. They said there could be weird aquatic creatures. If there's water, there could be things like squids, jellyfish, floating in their depths. They might use bioluminescence to communicate, a lot like deep-sea creatures on Earth. I personally think, not to derail myself here, but I personally think squids and all of the cephalopods are aliens, 100%. You don't get squids and octopus and cuttlefish and all that stuff. That is some alien technology right there. This was an interesting one. They said gas giant floaters. On planets like Jupiter with thick atmospheres and no solid surface, life might be vast floating organisms like balloon-like beings drifting in the upper atmosphere, feeding on chemicals or light. Carl Sagan once imagined entire ecosystems in Jupiter's skies having floaters or sinkers and even hunters. So the thought of giant intelligent gas organisms is kind of terrifying. I'm gonna do just a couple more here, but energy-based life forms, pure science fiction, but some speculate life could exist as plasma entities in stars or as conscious electromagnetic fields. I kind of touched on this one a little bit. Machine life. What if the dominant life forms out there aren't biological anymore? Maybe aliens created AI that evolved far beyond them, and now it's machine civilizations out there roaming the stars. And the last one is spiritual or psychic entities. Getting more speculative here, but some think alien life might exist on a different dimensional level or as pure consciousness, things we can't even detect because we're not equipped to sense them. And I personally lean into that. I think that this extraterrestrial life that is out there is most certainly interdimensional. It's tapping into realms of reality that we don't have access to yet. And on a long enough timeline, we will have access to those realms and we will tap in to that communication field. But I think that AI hit the nose on that one. Spiritual or psychic, interdimensional, extra-dimensional beings of pure consciousness. At the end of these shows, I like to do a list of fun facts. And I thought for today, since we're going galactic and we're staying in the realm of space, I would do a list of fun facts all about space, galaxies, and the cosmos. Our first fun fact is that on Mercury, a day is twice as long as a year. Technically, one Mercurian day lasts 59 Earth days, while a year lasts 88. However, due to Mercury's very eccentric orbit and alignment with the Sun, the length of time from sunrise to sunset, known as a solar day, is equal to 176 Earth days, which is twice as long as its year. I would not want that much sunshine. And I love the sun, but 176 days of sun sounds excruciating. This next one's a quick little fact, but all of the other planets in our solar system can fit between the Earth and the Moon. Next fun fact is that 1 tablespoon of a neutron star weighs the same as the human population. So that is just a did I say tablespoon? A teaspoon. 1 teaspoon of a neutron star weighs the same as the human population. That is so dense. And it weighs, a teaspoon of a neutron star weighs over 1 trillion kilograms. That is how dense a neutron star is. Our next fact is that gamma ray bursts release more energy in 10 seconds than our sun in its entire lifetimes. That's how the Hulk got his powers. Gamma radiation, gamma ray bursts, which makes sense. All that power getting sucked into them all at once. Our next fun fact is that black holes have theoretical opposites known as white holes. They're effectively the opposite of their dark relatives, spitting out light and matter instead of trapping it. And so far, these things are purely theoretical. We haven't found any, but astronomers are contemplating how they could form and work in reality. And our last fun fact is that Neptune has only completed 1 orbit since its discovery. Neptune takes a whopping 165 years to complete 1 full orbit around the Sun, and since it was discovered in 1846, Neptune only finished its first full post-discovery orbit in 2011. And that wraps up our fun facts, and also our episode for today. The Fermi Paradox isn't just a question of astronomy. It is a mirror to our place in the cosmos, our hopes, our fears, our dreams. All of this, it's a reflection of this. And maybe we're the first, maybe we're the only, maybe we are surrounded by entities we can't see, and maybe the silence that is out there says more about us than it does about them. If you've enjoyed this journey through the stars, through the cosmos, don't forget to leave those ratings, comments, reviews, subscribes, all that jazz. It only takes a second to click those little flim-flams, and it really helps this show get seen. And once again, huge shout out to all of my patrons. If you'd like to go that extra step, if you'd like to join us over on Patreon, to join your true family, come be one with us, that link will be in the show's notes. I'll see everybody next week. Until then, remember to check on your mental health and remember to check on the mental health of your loved ones. Bye.
Thoughts. Analog thoughts.
Analog thoughts.
Analog thoughts.